Yeah, good morning. Today we are going to discuss about the timer and counter in 8051. Okay. So the timer and counter it was plays major role in the timing based applications that we are going to discuss today. So in the microcontroller it's have two different timer, that is the timer 0 and timer 1. It's have the 16-bit length. Okay. It's have 16-bit. So because 16 bits you all know it is the started from 0 to up to 15. So here for your understanding purpose I started with 1 to 8 and to 9 to 16. It means it's have the 16-bit support, but the microcontroller it's have 8-bit support. But we are going to discuss about the microcontroller timer. So the microcontroller can support up to 8-bit data flow. So the timer, but the timer it's have the 16-bit length. So the 16-bit can be divided into two register. So likewise, so in the timer 0 and the timer 1, the two different timer. So the timer 0 also it's have the 16-bit length. So it can be divided into two register. That is the lower byte register timer. That is the low byte register timer, low byte register timer 0. Similarly, timer 0 high byte register, it is also having the 8-bit. Similarly, here also the 16-bit has been divided into two separate register, that is the TL0 and TL1. Okay, for the timer 1. For example, these two register it's have the data. This data we can access anywhere in the program. So for example, the move TL0, so the TL0 it's have the data, it can be moved to the 4H. Okay, for that particular address. So he can easily accessible. Likewise, the timer 1 also have 16-bit length. This is the total 16-bit length. Okay, so it is also separated into two different register, the low byte register and high byte register. It's have 8-bit. Similarly, this also have 8-bit. So it can be separated like this. So for the data flow purpose, because the microcontroller it support 8-bit data flow. So there is the same instruction, the data which is stored in the register, that is the TL low byte register, either high byte register we can access easily. So that was the example of the instruction. Okay. So this timer 0 and timer 1 can be operated some modes, like two different mode. So that can be written here. So the timer mode register. So here each timer it's have four different modes, like gate and clock bar timer. Select then mode 0 and mode 1. Suppose if you want to start the timer 0 or timer 1, you can use it for the gate. So the each timer it's have the four different modes. So we can discuss. We'll discuss one by one. So the gate it may used for start as well as stop the timer 1. This gate is may used for the start or stop the timer 0. So if you want to start the timer 1, you can give the instruction like set bit, that is the SETB TR1, that is the timer 1. If you are given this instruction, the timer 1 is getting started. Okay, if you want to stop the timer 1, you can give the instruction CLR TR1. Similarly, the timer 0, you can put the instruction SCTB TL0, sorry, TR0. So if you are given the instruction to the gate, the timer 0 is getting started. If you want to stop the timer 0, you can give CLR TR0. If you are given this instruction, it may getting stopped. So it means that the gate can be used for either starting or stopping of the timer. Okay. Similarly, the clock bar timer. The clock bar timer it can be used to make the delay generations. If you want to give, either you can give 0 or 1. So that may be used for the delay generation in the timer. Then the mode 1 and mode 0 can be operated in the four different mode. That both are, it is 0, 0, 1, 1, 0, 1, 1. So in the mode 1 and mode 2, if the value is getting value is 0, that is the 13-bit mode. If value is 0 and 1, that is the 16-bit. If value is 10, that is the 8-bit with auto load mode. Then the last one, that is the both are 1, that is the split mode. Okay, these four modes can be operated in the both the timer. That's all about the timer. So it's have the 16-bit length, two different timer you have, one is the 0 and another one timer is the 1. So it can be divided into two groups, one is the low byte and another one is the high byte. So we can access easily anywhere based on your requirement, you can access. Okay. Similarly, you must aware about the timer and counter differences. So the timer may be used to for the timing incremental applications, that is the from 1 to 0. The counter also the same, and it may be used for the 1 bar 12 crystal frequency. Then the counter it may used for the 1 bar 24 crystal oscillator frequency. So the crystal oscillator frequency is nothing but the microcontroller. It's have the inbuilt crystal oscillator circuit. It can provide the clock pulse as well as the clock frequency. So that may be used for our timing and counting application also. Okay.